Okay, so this lecture is on arithmetic progressions and geometric progression, and this focuses on the questions related to this topic. If you didn't watch the theory video before, I would highly recommend you watch it before you attempt to watch this video, because a lot of the concepts discussed in that video will be used in these questions. Okay, so let's start off. So we have questions here. The thing when doing questions, I advise is that you read the question first, okay, get a general idea of what they're asking you for, and then read it back a second time in which you write down the important information that they give you. This is particularly helpful in mathematics, but also in physics. It is extremely useful, okay? So let's read the question. The fourth term of an AP is 13 and the 10th term is 31. Find the 20th term. Okay, so first they say the fourth term is 13, so therefore the t of 4 is equal to 13. The 13th term, the fourth term, sorry, is equal to 13, and we say it's an AP. And remember, an AP is an arithmetic progression, which means it has a common difference d. Okay, now they tell us that the 10th term is 31, and what they want us to find is the 20th term. So normally what I would write is RTF, required to find, okay, the T20. Okay, so this basically gives us everything we need to know for the question. The fourth term is 13, the 10th term is 31. We are dealing with a common difference, and we are required to find the 20th term. Okay, so this is how we go about solving this question. This question is really simultaneous equations. So we know that the general equation from our first video is T of n is equal to A plus n minus 1 times d. So this is what we're going to do. So for the fourth term, let's deal with T of 4, okay? So we know that T of 4 is equal to 13. So we say 13 is equal to A plus 3d. Okay, remember it's n minus 1, so it'll be 4 minus 1, which is 3. Our 10th term, we know 31 is equal to A plus 31 minus 1, which is 30d. And notice we have two equations here. Okay, and these equations we could solve them simultaneously. So let's say this is equation 1, this is equation 2. If we do equation 2 minus equation 1, what we will get is 31 minus 13 is equal to, notice the a's will cancel because we'll get a minus a, which is equal to 30d minus 3d. So therefore, so 3 dots means therefore, okay, 18 is equal to 27d. Therefore, d is equal to 18 divided by 27, which simplifies to 2/3. Okay, so we know what d is, and given that we know what d is now, we could substitute this into one of the equations to find a. Okay, so we'll use 13 is equal to a plus 3 times 2/3. Okay, therefore a is equal to 11. Okay, now we know what a is, we know what d is, so could we not find the 20th term? So therefore T20 would be equal to a, which is 11, plus n minus 1, which is 19, multiplied by d, which is 2/3. And this would give us the 20th term in our sequence. which is equal to 71 over 3. Okay, so we found T20. Most of these questions are going to involve us using simultaneous equations if they don't give us A and they don't give us D. Okay, so now we have a next question. Find the sum of the first 20 terms for the AP given below. So we know it's an AP, so therefore it is a common difference we are dealing with. Okay, and they gave us some terms. So from this, we know this is U1, which means this is the first term. So therefore we know that A is equal to 15. Okay, we know what A is already. Okay, now we want to find the common difference. The common difference, all we have to do is say 18 minus 15. So we subtract these two terms and we get 3. And if you want to double check, you could just say 21 minus 18, we still get 3. 24 minus 21, we still get 3. So we know that the common difference is 3 and the first term is 15. Okay, now if we want to find the sum of the first 20 terms, we have an equation for that. S of 20 is equal to n over 2 multiplied by 2a plus n minus 1 multiplied by d. This would be equal to 20 over 2 multiplied by 2 times 15 plus 19d, which is 3. And this here would give us the sum of the first 20 terms. Okay, and this works out to be 870. Okay, so again, this one was pretty straightforward because it gave us the sequence, so we could have found A, we could have found D just from the sequence alone. Okay, so this differed from this question where they gave us terms and we had to find A and D. So let's move on. Next question. A sequence is given below. Find the sum of the first 10 terms and the sum to infinity. Now, they didn't tell us whether it's an AP or a GP, okay? But just by looking at it, and from the question, they asked us to find the sum to infinity. Remember that we didn't learn a formula for the sum to infinity of an AP because it doesn't exist, okay? So we're clearly dealing with a GP here, which is a geometric progression, which has a common ratio. But just to make sure, let's find the common ratio. R is equal to 9 over 27. Remember, it's the second term over the first term, okay, which is equal to 1/3. And just to make sure, we could also find 3 over 9, which is also equal to 1/3, or 1 over 3, which is also equal to 1/3. So we know we have a common ratio, which is equal to 1/3. And we know here that the first term is equal to 27. And what this question asks us to find was the sum of the first 10 terms and the sum to infinity. So the sum of the first 10 terms, remember we learned an equation for this, it's A multiplied by 1 minus r to the power of n all over 1 minus r, which is equal to A is 27 multiplied by 1 minus r, in this case r is 1/3, to the power of n is 10, because we're going to find the sum of the first 10 terms, all over 1 minus 1/3. Okay, and this is what we get here from this equation. Okay, so I'm not gonna actually find the value for that, I'll leave that up to you all. Okay, but at least you understand how we arrive to the answer. Okay, because you'll definitely get a pretty weird number for this question. Now they ask us to find the sum to infinity. Remember, the sum to infinity is given by the equation A over 1 minus r. Now, remember we had a condition for the sum to infinity. What was it? R must be between minus 1 and 1. Okay? Now, in this case, our R is 1/3, and 1/3 is between minus 1 and 1. So, therefore, we could find the sum to infinity. So, all this does now is we say A is 27 over 1 minus r is 1/3, which is equal to 27 over 2/3, which is equal to 81 over 2. Okay, so here we were able to find the sum to infinity and the sum of the first 10 terms. Again, remember these things, it is important that you know the equations. If you don't know the equations, you can't solve them. Okay, and remember what the terms represent. A is the first term, r is the common ratio. And this is our last question here now. Can the sum to infinity be found for the sequence below? No. They aren't asking us to find the sum to infinity. They are asking us if we could find the sum to infinity. Can. Notice the word can. Do you have the ability to find the sum to infinity? Does the sum to infinity exist? And remember, we said that for the sum to infinity to exist, r must be between 1 and -1. So basically, all they are asking us to do is determine whether or not r is between 1 and -1, because then we could determine whether the sum to infinity exists. Now, we don't even need to find the first term, we just need to find r. So again, r is equal to un plus 1 all over u of n, which is equal to 5 over 1, okay, which is equal to 5, okay. Again, we could use 25 over 5, which is 5, 125 over 5, which is 5. So we know that the common ratio exists for all consecutive terms, and the common ratio is 5. Now, is 5 between -1 and 1? No, 5 is greater than 1. So all you have to say is therefore, since r is equal to 5, which is greater than 1, the sum to infinity cannot be found. And this is a fairly understandable topic, because think about this, right? If the sum to infinity represents a value in which you add up all the terms in a sequence and they're supposed to approach this value, okay? But the terms here keep getting bigger and bigger, right? The values here keep getting bigger, so therefore it is really impossible to find the sum to infinity. In this case, actually, the sum to infinity would actually be infinity, because if you keep adding the terms, you would eventually reach it. If you was to add in an infinite number of terms, you would reach infinity. Notice, however, if r is between -1 and 1, the sequence would actually get smaller. For example, it go from 1 to 1/3 to 1/9. Okay? If you realize these terms here, if r is between -1 and 1, they keep getting smaller. And this is why you could actually find in sum to infinity of those terms. Okay? So this was the end of our video on EPs and GPs questions. I hope you all learned something, and do look forward to the next video. Thank you.